Let me preface this by just warning some of you who come in contact with the Orange Button before. This is not what you may have seen 3 or 4 years ago. I'll give you a little bit of the off-the-record story about the breakup and the recovery process. So I hope this is useful for you. I want to acknowledge, my co-author, Jan Rippengale of Blue Banyan Software. If you deal in the residential solar market, you may have come in contact with her company or her product, Solar Success. It's a fact that data friction adds to the soft cost of PV systems. Anyone involved in design, engineering, performance analysis of systems knows that you often have to exchange data with partners. If you're lucky, those partners open that data to you through an API. If you're not lucky, they email you a spreadsheet, and then you get to interpret inscrutable column headings and reformat timestamps. And you get to do that every time they send you a new spreadsheet format. Some estimates put this data friction cost at a substantial fraction of the 36%, which comprises soft costs. I think it's probably on the order of 1/3 of that, so 10% of the total cost of a solar system. It's comparable with some of the hardware that we buy. That friction evidence is in man hours spent simply manipulating data from one application to another. As an example, for those working in API space, here are the programmatic names given to GHI by 5 different services. There's G(H), which stands out by itself. There's lowercase GHI, but it comes in different units, and it comes in different timestamping conventions, interval versus beginning versus end. If you move to uppercase, one API didn't specify these quantities. One said, I'll give you GHI at different resolutions, and I'll change the time labeling depending on the resolution you ask for. These are issues which can be addressed with a little bit of automation in the API and conformance with a taxonomy, which is what I hope to discuss today. I'm not saying that this is the answer to the problems. I'm saying this is an opportunity that may serve to grease some of these data frictions. The Orange Button Initiative was a DOE-funded project started 5 years ago to address data exchange issues. It ambitiously sought to serve the entire life cycle of solar's power plants, from conceptualization, design, financing, construction, through operations, maintenance, and retirement. We do have an active working group chaired by Jan at Blue Banyan and myself. And what we hope to do is to promote an open data exchange standard. It is targeted currently at the distributed solar industry, but I don't believe that precludes it from being used for commercial and utility scale. A data exchange standard, when it's mature, will comprise a taxonomy, and I'll talk to you about what that is and show you some examples of what it looks like. Tools to access reference data sets. I want to show you one that's in operation, and a compliance test suite where you can test your code against the Orange Button schema and make sure that what you send is intelligible to others. That doesn't exist yet, but it's in the design stage. Okay, so instead of showing any equations, there's not a single one in this talk, which is a little foreign to me. I get to use the big words, taxonomy and semantic architecture, and I don't really know what those mean, but this definition helps me frame it. The taxonomy at its heart is a dictionary of terms, but it's more than that. It's a structured dictionary in the sense that you can describe a hierarchy between terms, and you can group like terms together to form information models that then communicate meaning. The advantages of using a taxonomy rather than just coming up with your own intuitive terms is it provides consistency but among applications. So 2 APIs using the same taxonomy will use the same term for the same quantity. You could connect terms together, as I described, into report kind of structures. And it's going to remove some ambiguity because you can attach metadata to terms and their values, such as timestamps. So how would you use it in your software? The Orange Button taxonomy is currently, it's open source, it's public, it's free to use. That's the way we think it will stay. The delivered in JSON file, which is compatible with Open API specification. We decided to use JavaScript style conventions rather than Python or Java language naming conventions for terms. There's the URL to GitHub. You can download it. It's in a single JSON file. It's kind of lengthy, but it's all there in one piece. JSON's not friendly to read. So there's an editor that is run off of the server at Sunspec. You download the JSON file locally, you open the editor, point it at your local file, and then you're able to search and browse, and it renders the taxonomy in a pleasant way to view it. The documentation, which you would find at orangebutton.io, is really dated. That's something that we need to address as a working group, but it's a small group of people, so that's just not going to be done anytime soon. So how does a taxonomy interact with your software? This diagram, I hope, conveys the essential point in that a server software, the owner of the data on the far right, brings the taxonomy schema into his application and essentially writes a toOrangeButton function or something equivalent that takes their internal data and writes it to a JSON file using OrangeButton terms. That instance then can be communicated to anybody else who is also using OrangeButton technology. And the receiver software has a read from OrangeButton function that knows which terms to look for and moves them to their own internal names. So those 5 GHI terms I showed you before, there is a term in OrangeButton for GHI. You simply write to that term's name and read from it, and then it doesn't care what on your application side what variable is used to hold that quantity. Here's an example. This is a screenshot from the editor of what might be there, and it's kind of important to understand how it's structured. The taxonomy at its base has a number of elements that are all intended to contain single values, and they're intended to be reusable in different contexts. So here's one generically labeled energy AC. Every element in the taxonomy has got the same set of, we call them, sorry, I just lost my train of thought there. We call them primitives. And you think of it, this is metadata about the energy AC term. You can specify a decimals or a precision. If that's important to you, you can specify a start time and an end time. The value is contained in this final primitive, and you can select and communicate a unit for that value. Individual elements can be packaged within a hierarchy of objects. This one we titled energy measurements. It's plural, meaning it's an array actually of a singleton energy measurement. They can be partnered with other elements. This is a device ID, which would contain a string communicating, for example, the serial number of the meter or your nickname for it that read this particular value. Objects that are a bundle of elements can be further grouped into higher level objects, and then so you can construct a hierarchical data model from the bottom up. Here's a couple of examples of instance documents. So if I had a piece of software that wrote to OrangeButton and I looked at the JSON file it produced, perhaps it would make something like this. And this is just a snippet of it. There would be some header information up here, which I can't describe intelligently to you, other people could. So I just clipped it out to show you what the value section would look like. Here's an instance of the energy AC object. We assigned it a 50.1 value in units of kilowatt hours. We use ISO 8601 timestamp conventions. There is a companion object to it we call the energy AC array. JSON has the capability of having arrays as values. That's indicated by the square brackets. So that allows me to communicate a sequence of instances of this same underlying element. Now you might look at that and say, that's a really awkward way to send me information that would be naturally in a column of a spreadsheet. I agree. We went back and forth on whether this was the right way to encode, a good way to encode this data. And I'll tell you that there was opinions on both sides. And we finally ended up just going with this selection because it removes ambiguity about which timestamps belong to which values. If we'd done the alternative and assigned energy AC itself, its value as an array of numbers, then we would also have to have a companion element that communicated an array of timestamps. And then we'd have to trust the user to realign everything. And we think that this is at less risk of being misunderstood. I have a screenshot of the editor. I'm not going to demonstrate it for you. It's open. There's no registration required. So just open orangebuttoneditor.com and or .org at sunspec.org and off you go. I wanted to put this illustration up here because it shows, and I can't even see it from the stand. Here's a high-level object defined called a PV system. Examples of the individual valued elements that live within it: capacity AC, capacity DC, a bunch of identifiers, and then some child objects: bill of materials, bill of services, energy models, energy production records, arrays, devices. Orange Button Development has followed the use case, and Blue Banyan's use case is to support the sales, design, construction, commissioning of residential systems. And that's what this information model follows. The editor is an actual editor. You can use it to make changes. You can add new terms. You can rename terms. We use pretty typical GitHub work processes. So if you're interested in contributing, and you say, I need a couple more terms in Orange Button for what I need to do, you compose that in the editor. You open a pull request. It goes to the GitHub. The committee debates it, etc. We comment on it. It's intended to all be public. I want to also show you an application that if you have used, then you are using Orange Button. You just didn't realize it. Okay, so this is the authority having jurisdiction registry. And if you are involved in permitting solar plants, I have been told, I haven't done this myself, that it's a pain in the butt to figure out which jurisdictions have authority over that particular address. So here's a lookup service. You type in an address at the search bar. We need a cursor. There we go. This happens to be the address of the hotel you're sitting in. Off it goes. Up comes a list of, this accesses a database NREL compiled a few years ago. The database itself has a maintenance process. We're trusted that we get crowdsourced reports for errors and corrections its updates. Here are the jurisdictions that have supervisory authority over this location and some of the building codes that they have that they apply. That application is enabled. The client server interface works on Orange Button terms. So let me switch back to my presentation. All right, so a word or two about my partner. I'm briefing her business slide for her. I can't do this justice. Blue Banyan has built a product called Solar Success, which aims to integrate the data processes at the front end, and I said primarily residential. So the diagram on the left was her visualization of the state of the art. Diagram on the right being an orderly system for managing the data involved in developing, selling, and installing residential. Somewhere on the order of 25% of the residential capacity that was realized in the U.S. last year was done using their services, and so Orange Button had a large role in contributing to that much of the development. This is a real product with people committed to using it. This is Blue Banyan's development roadmap, that they intend to take Solar Success outside of just residential and also enter operations and maintenance markets. And they view this taxonomy as the vehicle for being able to deliver that value to their customers. So in conclusion, I'll remind you, if you're curious about it, download the JSON file from that GitHub repository, open the editor, point it at your local file, see what's there, see what's missing. If you have an interest in contributing to this, or you think that your company sees value or potential value in using this, please contact Jan and I. We have a working group that meets twice weekly. It's analog. We get on the phone and on video calls with each other, and we talk through these development issues. But all the software changes are done through GitHub in an open asynchronous way. Thanks for your time.